Our next speaker is Steve Brown, who is a transformative visionary at the intersection of AI and healthcare. But that's not all he is. He's a serial technology entrepreneur. He's a Stanford-trained physicist and an award-winning filmmaker. He pioneered remote patient monitoring, helping shape Medicare reimbursement for remote care, and holds more than 200 separate patents. He previously served as Chief AI Officer to Peter Diamandis. He is the founder of CureWise, which harnesses AI to advance cancer care. And his mission is to ensure that every patient has access to AI-powered insights that can mean the difference between missed diagnoses and life-saving interventions. Please welcome Steve Brown.
So actually, I've been working in AI since, well, I have patents. I have AI patents that have already expired. So I've been working in AI a long time. For the last 3 years, I was working on things that were mainly around education. So bringing back to life all kinds of great thinkers from history so you could talk to them and learn from them, and then you could have them talk to each other. I was doing some of the very first things where I had AI agents autonomously talk to each other and debate each other. And it was a really interesting way to explore knowledge, and it was super entertaining. But then 14 months ago, the Palisades fire happened in Malibu, where we lived. And in the middle of the night, we had to evacuate, and by morning, our house and all of our belongings and everything was completely gone. So you would think that that might be probably the worst thing that happened 14 months ago in January. It turned out to be actually the thing that probably saved my life, because I had been treated by doctors in Los Angeles for a whole bunch of symptoms like abdominal discomfort and fatigue, and then 25 pounds of weight loss and feeling freezing cold all the time and didn't know what was going on. And I went to my doctors, like probably all of you would, and said, test me for everything. Give me the full body scan, do the endoscopy, the colonoscopy, the cardiac function test, do everything. So I did that, and I had all kinds of data. But the conclusion of the doctors was maybe you're just stressed out, and maybe it's just indigestion, and literally got a prescription for Gas X. And it was not that. But this happens a lot in medicine. I don't know how many people in this room have had that kind of experience where something serious sort of gets brushed off. Until it gets much worse. So anyways, after the fire, we were displaced to near Palm Springs, staying with friends. And after a steak dinner, I ended up in the emergency room. So, I'm doing what everyone else does. It's like, what do I need? How do I need to, what do I tell them so I can get to the front of the line? What do I tell them so that they'll recognize that I'm in horrible pain and they'll do something? And I had my line all figured out. It's like, I need a CT scan to rule out obstruction. I thought a piece of steak had stuck somewhere. So anyways, the young ER docs in Rancho Mirage, California, redid the scan. I mean, I just had scans. I had tests. I had all this stuff a couple weeks before. They did a new scan. They did a bunch of new tests. And they told me it's cancer until proven otherwise, and admitted me to the hospital. So I'm in the hospital, and well, first of all, if you get diagnosed with cancer in the emergency room, it means somebody missed something. That's not usually how cancer is diagnosed. It's usually people figure things out, and maybe it takes them a while, but it's not usually something you hear in an emergency room. So anyways, while I'm in the emergency room, I've been working a lot with AI. So the first thing I'm doing is going back to my AI, and taking my great thinkers from history AI for education and repurposing it to look at my medical record. And my first question was, why didn't they find this sooner? My AI went through the same data and immediately said, you probably have some kind of plasma cell issue, ask for a free light chains test, and maybe you need a bone marrow biopsy. So the AI immediately said the one thing that the doctors missed, one thing the doctors didn't do. So that, I'm doing this in the hospital. I'm there with my computer. I'm on all the pain meds, Oxy, and even had some morphine and fentanyl and all the good stuff. I'm back to my computer. I'm writing code, and I'm trying to figure out how do I use AI to look at my medical record. Now, if you've used AI, I'm sure everybody in this room has tried ChatGPT, and probably some of you use it for all kinds of things, and maybe some of you use it like 10 times a day like me. But you know that depending on how you ask the question, you might get a different answer. And that's not very comforting if you're dealing with something really serious like medicine. You kind of want an authoritative, deterministic response. You don't want to, if I ask the question differently, I get a different answer. But I looked at that and I said, well, actually, I've got 5 different doctors by now, and they all give me different answers too. So maybe that's not necessarily a bad thing. Maybe we actually want a diversity of answers. Maybe we want a lot of different ways of probing the AI to surface a lot of different answers. So I started working on this concept of a swarm of agents. So I actually built 36 agents for every medical profession and all the different research professions that I could imagine. And I used it against all the different models from Google, from OpenAI, from Anthropic, and from xAI, and a few other ones. And so I had like many different combinations, like hundreds of different combinations that I could try. And I basically ran them all against my medical record, asking similar questions in a little bit different ways from different points of view. And then I had them synthesize the results. So what you find is that, yes, they don't always give the same answer. And yes, there are different opinions, just like in the real world. But when you have them all talk to each other, and you look for convergence, and you synthesize that, you have a really interesting way of probing this vast knowledge set of all of humanity that's sort of compressed into this black box of AI. Like, nobody really knows how it works on the inside. I mean, we know in theory, like we all know how to make the little schematics of here's how it works, but when you scale that up to trillions and trillions of parameters, nobody really knows what's going on inside. It's a black box. So the only way you can really know is probe it from many different points of view. So that's what I was doing. And it came out immediately with the right answer. So what that told me is that this is going to be a very important tool in medicine. So I had spent much of my career in healthcare, working on chronic care, chronic disease management, remote patient monitoring, building systems to help keep people out of the hospital. It was very successful clinically, but a huge challenge from policy, insurance, regulatory, all of those standpoints. I literally had to get an act of Congress passed to make a market for what we were doing back in the early 2000s, and to get into the Medicare and to actually do these things. I was like done with healthcare. This takes too long. Life's too short to do another healthcare deal. But now I was not working on this for other people's problems. I was doing this for myself. I was not trying to start a business. I was not trying to, like, yay, there's a great startup idea here. I was just trying to see if I could figure out what was going on, figure out what the options were, and hopefully survive this. So let me see if this is set up and ready to go. See if we can do live demos on stage with getting through the firewalls. But anyways, I started building all these AI agents, and let me see if the sound is working here. And you can talk to them about your condition. So I have my entire medical record in here. See See if
Good to
she's
have
gonna
you
talk.
here, Steve. Let's walk through what's been found and what it means for you. You have two closely related conditions, AL, light chain kappa, amyloidosis, and plasma cell myeloma, multiple myeloma. In myeloma, abnormal plasma cells in your bone marrow overproduce a protein fragment called a kappa-free light chain. In AL amyloidosis, those excess proteins misfold and deposit in organs, in your case, the heart, digestive tract, lymph nodes, and bone marrow, causing damage over time. The encouraging news is that your treatment has produced a remarkable response. Your kappa light chains dropped from 439 mg/L at diagnosis to roughly 911 mg/L now, a greater than 97% reduction. Your heart marker, NT-proBNP, has also trended downward overall, though it bears continued watching. Your care team is managing this closely, and your performance status remains excellent.
So explain to me how is it that I had such a good response?
That's a great question, Steve, and your response truly has been exceptional. Several factors likely contributed to your deep response. First, your tumor cells carry a genetic change called TU11-14, a chromosomal translocation that makes myeloma cells particularly sensitive to venetoclax, one of your key medications. This is essentially a precision medicine match between your tumor's biology and your treatment. Second, your regimen, combining daratumumab, bortezomib,
So I'm gonna stop it there. The key point here was the treatment that ended up giving me a complete response and bringing me back to normal with like a disease that we can't even detect, and who knows if it'll come back at some point. But this was not something that my doctors said, this is what you need to get. This was something that I learned about by using AI, by talking to my AI agents and trying to understand what's going on with me and what are the options that might be out there for me. And then I went to my doctors and I said, I think I need this other treatment. I think that the standard of care, the guidelines are not going to work well on me because I have a different version of this. I've got a different mutation. And the first response from my doctors was, well, there's never been a clinical trial on this combination. It's off-label. Your insurance company's not going to pay for it. So no, I'm not going to do it. So I went to the Mayo Clinic, and then I went to UCSF, and I went to UCSD for a second and a third and fourth opinion, not to my doctor, but to my AI. And I told them, I said that I think this is what I need, and here's why, because of all the stuff that I've learned. And the specialists agreed that yes, if I were in your shoes, I would do that too. There was one phase 2 clinical trial on this combination of immunotherapy and this drug called venetoclax that was recruiting in San Francisco at UCSF. And so I reached out to the principal investigator and I wanted to find out about it. But the clinical trial had been canceled. There's a phase 2 trial, not even a phase 3 trial, but the clinical trial had been canceled. And the reason that the clinical trial had been canceled was because they couldn't get enough patients for it. So they needed like 10 people and they could only get like 8 or 9 people. The real message of this is if you look really closely at cancer, cancer is a mutation of your own genes in some unique way. So what that means is your genes are unique, and the mutations, there are a lot of different mutations that could have happened that led to it being cancer. Every cancer is unique. 2 million people will get diagnosed in the United States this year with cancer. It's actually 2 million different diseases, 2 million genetically unique diseases. And what we do in medicine is all of the knowledge of medicine, evidence-based medicine, is based on randomized controlled trials. Put people in a big group, vary one thing at a time, see whether or not that one thing makes a difference. But what do you do if everybody has a unique disease, if everybody is an N of 1? Which is actually the reality in cancer. the whole idea of a large randomized controlled trial breaks down. The whole way we've developed medical knowledge up until now breaks down. It doesn't work if everybody has a unique disease. So I look at that problem and I said, well, we're really at an impasse. The old paradigm needs to change. But we have this new tool called AI, which is phenomenally good at taking massive amounts of data from really diverse and messy sources where it's all different and it's not standardized. It's really good at taking that and predicting and inferring and making sense out of it. So I started to get better because my treatment started working, because I got on this other combination that was off-label and that I never would have found and I never would have gotten unless I had figured out how to advocate for it. Not just with my doctors, but then you have to fight the battle with your insurance companies. But I started saying, well, like, there's something that can help a lot of people here. And I started talking about it. And where Randy saw my talk, it was just about just less than a year ago. I was talking about it, and people started coming up to me saying, Steve, like you need to, like, this is what you should be doing. I mean, you should be productizing this. You should be bringing this to the world. And I was still at the state where I'm not sure if I'm going to be doing this. I've done startups my whole life. That's all I've done. I did startups, and then I did filmmaking, and every film is another startup. So I did lots and lots of startups. I'm always going into the unknown, starting something new. But if you know startups and you know entrepreneurship and founding things, it takes a huge amount of energy, and it's all-consuming, and you're working around the clock. So I was not saying I'm going to do a startup because I didn't even know if I was going to be able to survive. But I was charting my progress. Like every week I was getting new labs. I was charting this all out, and I said, if I get to this point where I get a complete response and I feel like it's going to be sustained, then yes, I'm going to do it. I'll do a startup around this. So that happened last year. I got to a complete response. It's been sustained, and we can't find any disease anywhere. And I also know like 10 other things we can do if whatever I'm doing now stops working, because I've done the homework on this. And we're just bringing now to market this application. What it does is it brings in your entire medical record, prepares it for AI, allows you to talk to a whole range of different medical AI points of view and learn. It's really about you learning what does my medical record mean? What is this all about? Then it helps you learn what are the options that might be available out there based on your unique situation. What tests should you be getting? What should you talk to your doctor about? Tests you should be getting to discover whether or not you have some unique mutation in the cancer that might indicate some other new treatment that's coming out that you might not have known about. What clinical trials are out there that might be able to help you? Medical knowledge is way bigger than any one human brain can contain. I mean, doctors are fantastic, and doctors really want to help people. That's why they did this, but nobody has a brain big enough to contain all of medicine now. And everybody's getting AI. Your insurance company's getting AI to figure out how to not pay for stuff. Your doctor's getting AI to probably figure out how to not get sued. But like, who has your back? So that's what we decided to do. CureWise is just focused on having your back, helping you understand what's going on, and helping you advocate for it. So that's where we are today.